class. All right, now we're starting circles today. So basically the first part of circles is all about vocabulary. If you want to do it yourself, you can. If you want to watch the video and copy it from my video, you can. So I'm just quickly go through it. I know by the time you copy down, you probably have to pause to write it down, but it's important you know what is a circle, like the real definition. What is a radius? What is a chord, or what does that look like? Okay, so in this case we have first definition is going to be circles, and circles is a set of points equidistant from the given point, which is the center, and we always label a circle by what the center is. So in this circle here is called circle P. Okay, the second definition is a radius. A radius is a segment with endpoint at the center and on the circle. Okay, let me pause this first. All right, what is a radius? And it starts at the center and ends in at a point on the circle. So in this case, this is radius AP. The third one is a chord. A chord is also a segment with endpoints on the circle. So this is an example of a chord. Just remember, it has to end at the circle, on the circle. So from J to K, that is a chord. What is a diameter? A diameter is a chord that passes through the center. So this is the key word. It's a chord, right? So it has the definition of a chord where the endpoints are on the circle. And then, but this, what makes it special is going to be it passes through the center. Of course, diameter is going to equal to 2 times the radius. Okay? A secant is a line. Okay, this is a line intersecting the circle in exactly 2 points. So when you extend a chord, it becomes a secant. Tangent is a line that intersects at exactly 1 point, only one. A secant intersects 2 points, a tangent only intersects at 1 point. Point of tangency is where's that point? The point at which tangent line intersect the circle. So here, this is a tangent line. It intersects the circle at Q. That's why it's called point of tangency. All right, next definition. What is a central angle? I mean, the word itself kind of guides you what it is. It's the center angle. An angle with the vertex at the center and the 2 sides are the radius. So this is going to be my radius. This is going to be my radius, right? That makes it the center of the central angle. Inscribed angle is the one that is being created by 2 chords intersecting on the circle. On the circle, that's the key word. An angle with the vertex on the circle, the 2 sides are the chords. So when the 2 chords intersect on the circle, it's called inscribed angle. An arc is a portion of the edge of the circle defined by 2 endpoints. The symbol is, we use this arc symbol. Okay, I'm sure you guys have heard minor, major, semicircle. Minor is less than 180. So if you're a minor, your age is less than 18 years old, right? So the same thing, if it's a minor arc, the measure of this arc is less than 180 degrees, and we'd use 2 letters to represent it. If it's a major arc, it needs to be more than 180, and we use 3 letters to name it. Okay, if I say AB, you don't know to go to this side or the other side, but if I say ACB, you know we're talking about the major arc. Semicircle, I'm sure you all know, it's half a circle. Half a circle. All right, so these are the 3 formulas. We have one more to add at the end that we're going to be working on. So A is pi radius squared. R is the radius of the circle. Circumference, which is represented by C, is 2 pi r. C equals to pi d, or pi times the diameter. Whichever way you write it is going to be fine. The arc length, if I'm only interested in knowing what is the measure of I'm going to do the length of the arc is x times c. C is represented by the circumference of the circle, and X is the degree. So we're also going to talk about a sector, which is an area of a portion of a circle that if I wanted to know the area, and you'll see the formula. So A equals to the same formula, but the only thing is it's going to be X times big A, okay, which is area of the circle, and divided by 360. Okay, but we'll talk about this more. I just want to add it into the formula. Okay. All right, so the next thing I want you guys to do, well, we'll do this in class, but this kind of defines if you really understood what we're talking about. So it asks you what is LQ, and just one thing I want you to make sure is you tell the difference between, is it a line or is it a segment, right? I know it's kind of hard to see maybe, but I think, like, you see UT is the line, but QN is the segment. So if it's a segment, make sure you're picking, it's either a chord. If it's a line, it's either a secant or a tangent line. So make sure you just pay attention to it, but we'll do this in class, okay? All right, next page is talking about circumference, an area of the circle, right? We already wrote down the formula for it, so rewriting it again here is not going to be difficult, right? So area of the so A equals pi radius squared, and C equals 2 pi r, or you can write C equals pi times d, which is the diameter of the circle. So whichever way you write it down, it doesn't matter. So kind of one thing I want you guys to pay attention is read the direction for this question, okay? So in this case, it's A, find the area of a circle for number 1 and 4, okay? Number 1 to 4, right? And then circumference from 5 to 8. So area of the circle is for number 1. So I'll just do 2 problems here, and then do 2 problems for 5 and 8, and then you guys can continue. So area here, so area is pi radius squared, right? So what is my radius in this case? Good job. Pi 12 squared. So the answer would be 144 pi. So you can put that in a calculator and find the answer. So this one is just asking you what is the area, so it doesn't really ask you to leave the answers in terms of pi. So I would multiply 3.14 times pi. So what I will do is I'll put the calculator, because it kind of helps you to understand where pi is in a calculator, right? All right, so in this case, so pi is this symbol right here. Do you see it? So you're going to put 144 times, see the sign on top of the, so you put second pi, okay? So that's the answer. You can just leave it like that, especially if the question is asking you to leave it in terms of pi. But if not, you got to write the decimal point. So it's 452.39. So I'll put here 452. So here I'm going to put 452.39. Okay, that's the answer. So number 2 is the same thing. Area is pi radius squared. Area is pi, what's the radius? Good job, 9, right? Not 18. So area would be 81 pi, or this is approximately what? So pull your calculator, you put 81 times second pi, or you just put second pi next to it, which is this sign here. Gives you, enter, 254.47. 254.87. Okay, that's what we have to do. So I'm going to let you do 3 and 4. If you get a chance, you can do it at school or you can do it at home, whichever one. All right, number 5 is finding the circumference. So C is pi times d, or 2 pi r. So if they give me the radius, I'll use the second formula. So in this case, I'll put 2 times pi times 7, which is 14 pi, right? And then times 14 pi in a calculator, so 14 pi, which is 43.90, 43.98, is that what it says? Just verify, 98, yes. So I'll do 7 because 7 gave me the diameter. So since it gives me the diameter, I'll say pi times d. So C is going to be 58 pi. And then since they did not ask me to leave it in terms of pi, I will multiply it out. So 58 times pi symbol right here, equals 182.21. So this is approximately 182.21. Okay, so this is yard squared. Yard, you don't need to square it. This is millimeter. But when it comes to the area piece here, it would be meter squared and inch squared. Okay. So number 9, the direction is use the area and circumference formula to find the radius and the diameter. So in this case, find the diameter of a circle with the circumference of this. So I always like to write the, okay, so this is, I'm looking for pi d, right? I'm looking for the diameter, so I'll write it as C equals pi times d, but the circumference is given to be 65.97 equals pi times d. So I wanted to isolate d, so I'm going to divide both sides by pi. Okay, so you grab your calculator, then you're going to do 65.97 and then divide it by pi, which is this one, and then you press enter. The diameter is 20.998, so D is 21, because this is really close to 21, because 998, so when you round it up, it would give you 21. So the same thing with the area. The only difference this is you have to do a little bit more step because it has pi radius squared, right? Find the radius of a circle with the, oh, this is, sorry, this is circumference, so you have to do A is 2 pi r, and then divide both sides by, so area would be, so I want to do this because I was going to skip it, but I just want to make sure you guys, after you do this, you got to divide both sides by 2 pi, right? By 2 pi. I want to show you how you're going to put this in a calculator. So please don't just put 21.99 divided by, so let me move it to the side. 21.99 divided by, so if you put 21, so let me clear it out so that you can see it. So 21.99, and then just divide it by 2 pi like this. This is wrong, okay? Because what the calculator is going to do is it's going to times 20, it's going to divide 21.99 by 2, but times it by pi. So you don't want to do this, okay? That is wrong. So you can either use alpha y equals 2, and then alpha y equals, which gives you number 1, which gives you 21.99 over 2 pi. This would be the perfect way of writing it down. You can do it that way, which gives you 3.49, which is 3.5 for the radius. Or if you just do it the way you want to, just without the fraction, divide it. Make sure you open a parentheses and put 2 times pi inside the parentheses. No. Delete. 2 times pi inside the parentheses. This shows you 21.99. I don't know where I get the 9, the 8 from, right? Delete this one. Oh, delete it. 20. So 21.99. So it will give you both the same answer. So it's gonna be 3.5 is the radius. So just be careful, okay? All right, radius would be 3.5. Okay, so if you don't put the parentheses around or you don't put in a fraction, you are going to get a wrong answer. So find the radius of a circle. Circumference is given, so you guys can continue to work that. Now I'm going to do the distance part, the area part, right? All right, I'll just do 12 because that's where the area is given. So it says find the radius of a circle with the area of 380.13. So I'll still write the formula, which is A is pi radius squared, right? So the area A is given to be 380.13 equals pi radius squared. So I wanted to solve for r. So the first thing I'm going to do is divide both sides by pi. Okay. And then what I would get from there, I have to do the square root of that number. So I put 380.13 divided by pi. That gives you 120.99, right? So I try not to round it up too much. 120.99 equals to radius squared. So I need to know what the radius is, so I have to do the square root of 120.99 equals to radius. So I'll come to my calculator, and then I will do the square root of 120. If you want to put the whole number in, you can, but 99 would be better. Well, or you can put 121, right? So because that would round it up. So it's probably better to just do 21, because if you round it to the hundreds, it'll give you 21. So let's delete these two numbers. So approximately the radius is going to be 11. Okay, so radius would be 11. That is my answer. So that's what you guys have to do for this page. So we'll finish the rest of it in class. I just want to go over area of a sector. Okay, what if you have, and I don't know, from the paper you should be able to see it, but in this case we'll do more of, so this is shaded region. So you're looking for the shaded region. These are the shaded region. These are the shaded region. These are the shaded region. Okay, it's kind of hard when you copy it. And this is the shaded region, and this is the shaded region. Okay, so I'll go over this more in detail, but I just need you to know what is a sector. So say a sector is a region of a circle bounded by the central angle and its minor arc. Okay. All right, so this is the definition. A sector is a region of a circle bounded by a central angle and its major or minor arc, because in this case, most of the time it's going to be minor arc. So this is the central angle. This is the minor arc. So I'm looking for the shaded region. Okay, that's what we're looking for. What is the area of the shaded region? So the formula is going to be x times pi radius squared times 360. What is x? X is the degree measure, and usually they would give it to you what the degree measure of the arc is. So in this case, I think this was 60. So if I wanted to find the area of the shaded region, I will do 60 times pi times the radius is 8 squared divided by 360. Right? So the best way to put this in your graphing calculator is using y alpha equals to all right, so this is what you have to do. Divided by 360 in your calculator. When you press enter, it gives you 33.5y. If I was looking for the area of the whole circle, I'll just have to do pi times 64, right? Because 8 squared gives you. So this is the whole circle. 201.06 is the whole circle. But I'm only looking for the shaded region, which gives you, that's why I have to add the 60 into it, which gives you 33.54. Okay? So this is about it for today. This is kind of 5A page. I added at the last minute. We'll finish it everything in class when I see you next. Okay?